Okay, for this lesson, we're going to start taking a look at trigonometry. So when we were doing grade 10, we basically just did right angle trigonometry. Now that we're expanding into grade 11, we're going to look at larger than right angle or larger than 90-degree rotations, as well as non-right angle triangles. So there's some terms that we need to learn first. We have angles in standard position. Now, anytime that I'm doing an angle in standard position, this would be fitting an angle on a grid where I have a y-axis, I have an x-axis, and then it is going to start on the positive values of the x-axis here, and it's going to rotate out from there. Now, like it says, angles can be measured in degrees where 360 degrees is one complete rotation, but I could go well beyond that. I could go up to 540 degrees, I could go over 1,000 degrees, and it's just going to keep rotating around that point. We refer to that as the rotation angle. So I start from those positive x values, or my initial arm, as it says here, and then it's going to rotate from that point, starting at the origin. Now, like it says, if we rotate counterclockwise in this direction, like what we see here, that would be a positive angle. If I chose to rotate in the other direction, and this was my theta, then that would be a negative angle. We refer to this as standard position because, like I said, the vertex occurs at the origin, 0, 0, and the initial arm runs along the positive portion of the x-axis. We can see what this would look like if I had a 220-degree rotation in standard position. So I have my initial arm here. I have my terminal arm. Over here. Here's my rotation angle. And this is 220 degrees. So it rotates past the 90 degrees, which would be the first right angle, past the 180, which would create just a straight line, and all the way down into that third quadrant. When it asks us to sketch the rotation angle in standard position and state the quadrant in which the angle terminates, I'm going to start with a point at the origin. I'm going to show my initial arm going along the positive values for x. And then it doesn't need to be perfect. I'm just going to show my terminal arm existing in approximately the point where it exists. So if I'm looking for 120 degrees, that's going to be in between the 90 and the 180, and it's going to be closer to the 90. Like I said, it doesn't have to be perfect. And I'm going to indicate that it is rotating in this direction. And there is my theta, or my 120 degrees. If I'm looking at how this fits in the quadrants, remember it starts in the top right for quadrant 1, and then it goes counterclockwise to quadrants 2, quadrant 3, and quadrant 4. So it terminates in quadrant 2. When I go on to my next example, same thing. Show my initial arm. 309 is in between 270 and 360, and it's going to be closer to 270. There is my rotation, and it ends in quadrant 4. For my last example, show the initial arm. It's going to be between 0 and 90, and it's going to be closer to 0 degrees. And that ends in quadrant 1. So those were our angles in standard position. And it's asking us, what is the rotation angle going to be? Well, my rotation angle is literally just where that angle exists in between those two values. So my rotation angle for this one is going to be in between these 2 points. For the second one, it's saying that's going negative, and it shows my initial arm, and it shows my terminal arm, and it's going to go in this direction, or clockwise, to show that it's negative. The last one is going 510 degrees, still has the initial arm and the terminal arm in the same place, but this one is going to be positive, so it's going to rotate in this direction. But it's going to go around more than once and then wind up back around there. We call these coterminal angles. Co meaning that they're going to cooperate or line up with each other, like collinear, and terminal because they have the same position for the terminal arm. Since 150 degrees is the smallest positive rotation, we call that the principal angle. So even though 150 degrees or negative 210 degrees or positive 510 degrees would wind up in the same place, the smallest possible positive version of it is my principal angle. That's always going to exist between 0 and 360 degrees. And we know that we could keep going in the negative direction or keep going in the positive direction, and every 360 degrees, we'd wind up at the same point again. So there's literally infinitely many possible angles that could be coterminal with any given angle. Sometimes we'll do it based on coordinates, where it says the point P lies on the terminal arm of the angle. Draw the angle in standard position. So I'm going to draw my y-axis. I'm going to draw my x-axis. And I have a x value of 2. I have a y value of -4. So I'd have a point that exists down here somewhere. Now I know that my initial arm never moves. It always runs along those positive values for x. It's going to connect at the origin, and it's going to run through my terminal arm here. And it doesn't say whether it's positive or negative, so we're going to assume that this is a positive rotation of theta degrees. For the next example, we do the same thing. I have my y, I have my x. I'm going to find that point of -5 and -1. I'm going to show that my initial arm starts along that positive x. My terminal arm is going to run along here and is going to rotate in this direction theta degrees. So those are our angles in standard position. We also use what are called reference angles. The key for reference angles is that it is always acute. Remembering that means that it is less than 90 degrees. In this case, it can be up to 90 degrees or between 0 and 90 degrees. And the key that people frequently miss is it's the distance to the x-axis or the horizontal axis. We never calculate it to the vertical axis, even if it's closer. So it says that the diagram shows the terminal arm of rotation of 141 degrees. There's my angle in standard position. It says that I have a reference angle of 39 degrees. Here's the closest x-axis. And there's my 39 degrees. Now, we know that a rotation angle we refer to as theta. We can add to that a reference angle is theta with a little subscript r.